Hey Geometry, welcome back. 8.3 in Big Ideas, Proving Triangle Similarity by SSS and SAS. So we're looking at these two theorems today to prove that two triangles can be similar. First, let's actually jump into just a quick little cartoon. This is a In the Bleachers cartoon by Steve Moore. Ernie, pluck yourself, wear skins. So if you ever played pickup basketball out on the playground, you know what we're talking about. Alright, let's move on to our theorem here, side, 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 SSS, similarity theorem. We have this also for the congruent theorem. And we can see that same SSS applies for both congruent triangles and similar triangles. The congruent triangles, then the corresponding sides would have to be congruent. For similar triangles, on this one though, the corresponding side lengths of two triangles are proportional. So we could see that if we could write a proportion out, they're all proportional, these all would be equal to each other, then we could say they're definitely similar triangles. We've kind of already looked at this a bit already with 8.1 and looking at if two figures, even two polygons, are similar. Now we can look at all their corresponding sides and see if they all have the same scale factor, and that's essentially the same thing as this theorem. So here's one, you can just watch this one and then we'll try a couple here. So is either DEF or GHJ similar to ABC? So ABC is here. We want to see, are these two similar to this one? Is either one? So we could start off by looking at some of their ratios. So we look at the DEF first. So we're going to first look at the shortest sides and see about those ones. So the shortest sides, the smallest side lengths, are here in red. And so it's going to be an 8/6 situation there. That would simplify to 4/3. Then we're going to look at the longest ones. So the ones that are longest are in blue here. So it would be 16/12. And that would also reduce to 4/3. Then we would look at the remaining. So if these two are simplifying to the same fraction, then we go on to the remaining sides. If these two did not equal the same thing, then we can say right away that these wouldn't be similar. But if they are the same, we go on to the next one. The remaining sides here would be the ones in green, so 12/9. That also reduces to the same 4/3, so we can then say yes, these are similar. And we do the same thing with this one as well. Okay, so on to that extra practice at the bottom of page 234. We're doing the same thing here as we saw in that last one. And you can just stop the video and try this yourself, just like you saw that last one. Basically we're going to determine whether RST, so that these both are labeled RST, and number 1 and number 2, are similar to this triangle up here, ABC. And so if we start with number 1, well then we want to look at their shortest sides first. So look at the short sides first. On these ones, we got the short side on number 1 would be 4, and the shortest one here is the 2.5. So we're looking at that. So 4/2.5, and we want to reduce this down. So to make this into not a decimal here with 2.5, we'd move this decimal, make it 25, which means we're going to add a 0 here to 4. So that it will equal 40/25. So now there's no more decimal in our fraction. And we just can reduce 40/25 down to its lowest form. That would be 8/5. So you can see 5 goes into the top and bottom. It becomes 8/5. Now let's look at the longest one. So the longest one on 1 here would be 8. The longest one on this triangle up here is 6. So that would be here 8/6. And we can check 8/6. We could reduce that down to its lowest terms, which would be 4/3. So since these do not match, these do not equal each other, then that means that these are not similar in these triangles. So these two triangles then are not similar. One is not similar to ABC. Let's try 2. So starting with the shortest sides, the shortest one on 2 is 1. So we'll start with 1, and the shortest one up here was at 2.5 again. So to start with short sides, that's going to be 1/2.5. So do the same thing, move this to make it 25. That makes this 10 on top. So we're going to see 10/25 and reduce that 10/25 again by 5, which would just make it a 2/5. Then we look at the longest sides. So the longest one on number 2 here would be the 12/5. 12 fifths is more than 2. 12 fifths would be like 2 point something. And then the longest one here is 6. So it's going to be, for longest sides, we're going to see the 12 over 5 on top and 6 on the bottom. Well, we don't want to leave a fraction here on the top. So what we could do is we could kind of change that to a decimal if we wanted to do it like that. That way it's kind of like what we did over here and here with the 2.5. So we could see that 12 fifths, 12 divided by 5 even, if you just wanted to do that, 12 divided by 5, that equals 2.4. So now it's 2.4 over 6. And then we can change this to 24 if we put a 0 down here and make that 60 at the bottom. So now it's 24 over 60, and we can reduce that both by, you could probably reduce it by 6, maybe even more than 6 now. I think about it as 12. Yeah, 12 can go into both of these. 12 goes into 24 and into 60, and that would give you your 2 fifths. 12 is going to 24 2 times, into 60 5 times. So far, we have these two fractions equaling each other. So now we need to look at the remaining sides. So our remaining sides here would be the 2 on this one and the 5 on this one. Those are the ones remaining. So just 2 over 5 already is 2 fifths, the same fraction as we got here. So yes, these are similar. And so we can just write a similarity statement that triangle ABC is similar to triangle RST. So yes, they are similar. Okay, here's another example from the book. We're trying to find the value of x that would make these similar. So we're just going to assume that they are similar and go off corresponding side lengths. And so we can say, well, all the sides are going to be proportional then. So we'd want to get one with x for sure. This is an easier one with x than this one. I may not use this one here, just use this one. So BC and EF. You can definitely see BC and EF are going to correspond according to up here. So these, it says it's similar, and so we're going to say all the corresponding side lengths are proportional then. So we can have an x minus 1 over the 18, and then use either one of these, but it would be easier to use it with a 4 and the 12 than doing it with this other one with x. So that's the way we'll set this up. We'll do these proportions here, giving us the 4 over 12. That's one of them with corresponding sides, and the x minus 1 over 18, that's the other one with the x. Cross multiply, so we're going to have to do a little distributive property with 12 here. So we have 4 times 18, 12x, and then minus 12 there on that. So 4 times 18 is 72. And then we're just going to solve for x, so we'll add 12 and then divide by 12, basically, giving us 7. And that's all we needed to do, find the value of x. Okay, so number 3 on your extra practice. Now we're on the top of 235 in your notes. We're finding the value of x that would make these two similar. So we're saying that these are similar here. And so we'll do the same kind of thing, set up an equation with what we have. So we want to figure out, look at some corresponding sides here. So we have one with x plus 7, that's GH. GH, that's going to be corresponding to SR, that would be the 3 here. The other one might want to use would be the ST. So ST and the GK one, that would be over here. Those are just numbers, so that would be these two numbers are going to correspond. So you wouldn't use 5 with 8, you'd use 5 with this 20 over 3. So first you want to figure out what proportion you're going to set up. So you need to look at corresponding sides. So we're doing ST over GK. So that's what I'm saying here. This one over this one, those are corresponding to each other. We could see that up here. ST, GK from these are corresponding. And then the RS and the HG, that's these two up here. So RS here. And notice we're doing the same triangle, making the proportion correct here. So we have corresponding going vertically, and then horizontally we're going to be using the same figure. So ST and RS are on the same figure here. These two sides are on the same figure here. So same sides going horizontally. So now we just plug in everything that are from these. So go ahead and plug it all in. So ST is 5, GK is the 20 over 3, RS is 3, HG is the x plus 7. Here we're going to cross multiply now and then solve for x. So when we cross multiply, we're going to get a distributive property here with 5 times x plus 7. And then 3 times 20/3 here, you can actually cross cancel the 3's as you're multiplying those. So if 3's cross cancel, you're just going to see 20 left on the right side. Over here we're going to see a 5x plus 35 is equal now to 20. And then we just subtract the 35 from both sides, and that would give us 5x now is equal to negative 15. 35 is bigger, so it's negative 15. Divide by 5, and we're almost done. And negative 15 divided by 5 gives us that negative 3 as an answer. So what's the value of x that makes these similar? It would be negative 3 for x. That would make these similar. So here's our joke of the day. What's a frog's favorite soda? What is a frog's favorite soda? Coca-Cola. Coca-Cola. Okay, number 4 on our extra practice there in the middle of 235. Verify that triangle RST is similar to triangle XYZ. Then find the scale factor of RST to XYZ. And so here's where we need to remember, this was what I was talking about in class, that we need to realize that this is kind of going backwards. So looks like this one will be on top and then this one's on the bottom, but we're actually going to put the XYZ on the top of the fraction as the numerator. RST is going to be our denominator. So it actually kind of goes backwards than what we think. So let's just start doing that as we're verifying that these are similar. So we just need to make, these are all corresponding sides here. These are your corresponding sides. So 3 corresponding sides here. You can see that because RS, XY, they correspond together even just on the statement. ST, YZ, those correspond. And so we're just going to put this, we're going to put 28 though over 12. We're going to do this one on top. This is going to be our numerator one, and this will be our denominator one. That way we can kind of just keep it where we're going to get the scale factor correct there at the end. So 28 over 12, we reduce that. We're looking at what goes into both of these, and 4 can go into both of them. So we're going to get 7 over 3 as a reduced fraction of the 28 over 12. And then we'll do the 35 over 15 for the next one. And we'll reduce this one by 5. And so when we reduce that, we're going to get 7 over 3 again. So far they're looking pretty good. And then the last one, we're going to do 56 over 24. Again, the XYZ is on the top. So we reduce this one by 8. 8 goes into both of these. We're looking for the biggest number that would go into those, our greatest common factor. And so that would also be 7/3. 8 goes into 56 7 times and into 24 3 times. Since all of these are the same scale factor, or they're all the same number here, they all reduce to the same number, that is the scale factor. Of 7/3 is our scale factor. So we can just circle one of them and say, okay, that's the scale factor. And that also verifies because these are all equal. It verifies it when we can show that they're all equal. All the corresponding side lengths are equal. So that's the scale factor. Okay, our last two on this extra practice, the bottom of 235, 5 and 6, it says the shortest side of a triangle similar to triangle ABC is 15 units long. Find the other side lengths of the triangle. So in this one we know ABC and all the side lengths for ABC, and we know one side length, the smallest one in fact, we know it's the smallest or the shortest, is 15 of some other triangle. We need to find the other two side lengths of that triangle. So it's similar. Since it does say that it's similar, that means the corresponding side lengths would be proportional. So we're going to start with just figuring out the corresponding side lengths, maybe figuring out the scale factor really of what we have. So we're looking for the shortest side out of these three, and that would be 6. So we're going to start with AB right there. So we're going to see 15 is over AB. So 15, the shortest side of this triangle, is going to be over the shortest side of our triangle here. And so we know AB is 6, so we'll just plug that in, 15 over 6, and reduce that fraction by 3, and that gives us 5 over 2. So the scale factor would be 5 over 2. And what we could do then is then figure out the other side lengths from that. So we're going to now use these other side lengths to figure it out. So if we say, the next one would be like 9, we can multiply 5 over 2 times 9 to get that side length. So we want to look at 5 times 9 is 45. So we'll be saying 45 over 2 could be the other side length, or that would be, you can make that a decimal if you want to. And then the last one would be from 7, so we're going to multiply 5 over 2, our scale factor, times this other one here to get the last side length. that's going to be 35 over 2 for our last one. And so that would be the other two side lengths of what we see. Then number 6 says the longest side of a triangle similar to ABC is 6 units long. Find the other side lengths of the triangle. So now we're told that the longest one. So we're going to do the same kind of thing, but now using the longest side, which would be 9 on this one here. So we'll start off with 6 over 9. So 6, the longest one of the triangle we're looking for, is on top, and then 9 on the bottom. So we'll put 6 over 9, and then we're going to do same kind of thing, multiply, or actually let's reduce this 6/9 by 3, make that into 2/3, so there's like our scale factor here then. And so now we can multiply 2/3 times these other ones. So starting with 6 is this other side from AB, and so 2/3 times 6, cross cancel with 3 and 6. That'd be 3 becomes a 1, 6 becomes 2, and now we just see 2 times 2 is 4. So 4 is one of the other side lengths. And then we're going to do the same thing with 7. So it's going to be 2/3 times 7. So 2 times 7, there's nothing I can cross cancel here. Just 14 over 3 is the other side length. And so there's my two side lengths of the other triangle. So just remember, and we can maybe see this as like a pattern here. What did we do the same on this one? Well, the number that they're giving us from that mysterious triangle is going to be going on the top. The number that we have from our triangle goes on the bottom. That's the same thing that's happening here. The 6 from the mysterious triangle is on top. The 9 from our triangle here is going on the bottom. So just realize that that's the way you want to do these. So put the number you're given on the top, and then the number that you have from the triangle that you have here on the bottom to get your scale factor. Okay, so we're not quite done yet. There's still a little bit more to come. We haven't talked about this side angle side similarity theorem. So this one, we did talk about this with congruence as well. So we could also prove triangles congruent with SAS, but it would have to be where the sides are congruent and the angles congruent. Here, the angle still has got to be congruent. As you can see here, x is congruent to m, but the sides would be proportional. For similar, the sides just have to be shown proportional, as you can see here. So sides are always being shown proportional on similarity theorems or in similar figures or similar triangles. The angles are always going to have to be the same and congruent. They have to maintain those same angle lengths. So I'm going to have you write some stuff down here. Let's look at one here first, though. You don't have to copy this one down. We're going to copy a couple other ones down on your notes here in just a second. So here's two triangles, as you can kind of see in this figure. It says you are building a lean to shelter starting from a tree branch as shown. You can construct the right end so that it is similar to the left end using the angle measure and length shown. So that's what we're making some kind of cover here. So they're showing you at 43 degrees on this triangle, or 53 degrees on this triangle, 53 degrees on the same or similar triangle here. So you want to kind of show that these are similar using that SAS theorem. So it says A and F are both 53 degrees. So far we have one congruent angle. And then we want to compare the ratios of the lengths of the sides that include that angle. So that would be the FG and the FH. Those are the sides that would have the angle in the middle between them. So AB would have to be proportional here with FG, and same thing with these two would have to be proportional as well. So we have to see that they are proportional. So the AB over FG is 9 over 6. Those are shorter ones. And then the AC over FH there, that's going to be 15 over 10. It's 3 over 2. It's also the same thing. So because those are equal to each other, and these are proportional sides then we can use the SAS and show that they are true. Okay, so going on to just what I want you to write. Okay, so at the top of page 234, right above the extra practice, you see the side angle side theorem there. Right underneath that, there's a little section of notes, a little space there. I'm going to have you put number 3 in that section. So just this number 3, go ahead and copy it down with the triangles here and the numbers. And what we're trying to do is, it says explain how to show that the indicated triangles are similar. And so what we're going to do here is use these theorems to show this. So first off, we see that it has these right angles. They both have a right angle here for R and N. So those two are congruent angles. So we could start with that. So down below these figures, go ahead and write that angle R is congruent to angle N. So that's one angle we know is congruent. And then if we can show that these other sides here on each side of this right angle are proportional, then we can use the side angle side, which is what we're going to try to do. So our proportionality here we want to do is starting with SR over PN. So using these ones, SR over PN, these are corresponding sides, which would be the 24 over 18, and we can reduce 24 over 18 by 6. So that becomes a 4/3 then as a reduced fraction. And then these other sides, we'll use those two for the other ones. So RT over NQ, RT over NQ, so it's the 28 over the 21. And we reduce these two by 7, and so they both become 4/3 as well. So both fractions reduce down to the same fraction here. And so that means that they are proportional. If they equal the same fraction, if they reduce down to the same thing, these corresponding sides are proportional, which now we can definitely say, so the two triangles, they are similar by SAS. So that's what you want to write there at the end. Now for this next one, number 4, I'm going to have you put this one on the bottom of page 233. So that's a little smaller over here, but the bottom of page 233, so if you flip back one page, right underneath the SSS, there's a little section of notes there. Go ahead and copy this figure down as well. And we want to, this one might be a little more challenging. It only gives us side lengths, doesn't give us necessarily any angles. We can, well, I guess we could use the angles as well, so we can do the angles, or we could do all the sides. So, this is a right angle. This means that this is going to be a right angle on this side as well. So we could do that, but we're going to use the side on this one, because we do have side lengths for everything here. So we start off with just the first one. So XZ and YZ, those are corresponding. It's best to go up here to look at these where we know XZ will correspond to YZ. So go ahead and put that one down, XZ over YZ. So that's the 12 over 9. So the 12 for XZ over the 9 for YZ. And so the 12 here is going to be going for this triangle though. So 12 over 9 reduces down to 4/3. Then we can also go to the next one, which is ZW over ZX. So if we do ZW over ZX, ZW, that's going to be this one down here with 16, and then ZX is the 12 again, so 16 over 12 also reduces to 4/3. And then the last one would be like doing these ones here, XW and YX. So those ones can also be our last ones, XW over YX, which the XW is the 20, the YX here is the 15. 20 over 15 also reduces to 4/3. And since these are all the same, they're all corresponding, side lengths are proportional, then we can say that these are similar by the SSS congruent theorem there. So that's what we want to do for our last one here. And there is one more page I want to show you, which is just a quick little summary of the 3 theorems that make these triangles similar. 3 triangle similarity theorems, and these are the ones we looked at today, and also in 8.2 was the AA similarity theorem. So AA is if you have 2 angles in one triangle that are congruent to 2 angles in another triangle, then you can definitely say those 2 triangles are similar. You don't need all 3, you can just have 2. All you need is to show that 2 angles in one are congruent to 2 angles in the other. And then there's the SSS showing that all sides are proportional. So if you can show that all corresponding sides of one triangle are proportional to the other one, then that would be another way of doing it with SSS. Or if you have one angle in between 2 sides that are proportional, then it also can use SAS. So the SAS, SSS, and the AA are our 3 to show and prove that triangles are similar to each other. Alright, so that concludes 8.3, and you want to go on to the assignment for 8.3, and I'll see you back in class.